So hello guys, once again I welcome here all of you in this marathon session of highway engineering. Today we're gonna discuss fourth part of geometric design. So so today our first topic is setback distance. Setback distance. Basically we denote it by letter M. Okay. Basically, as we discussed yesterday, there's two cases in this. When length of horizontal curve is greater than side distance, and when length of horizontal curve is less than side distance. So let's we discuss case first. When length of horizontal curve basically LC greater than side distance. Okay, basically we'll discuss it for two lanes, for single lane and for double lane. Before that, let's draw a diagram for the sake of simplicity. Something like this. Yeah, yeah, this. And one dotted line from here. Something like this. There's a line here. This is obstruction. This is alpha by 2. This is alpha by 2. The distance is r. This is center of carriageway. Carriageway. And this is our side distance from here to here. What it is? Side distance. Okay. And look, this distance. Yeah. Basically, this distance is our setback distance. It is, yeah, it is minimum setback distance. Back the distance. Okay. So here for single lane, as we discuss first for single lane, our setback distance M is equal to R minus R cos alpha by 2 in meters, where L is equal to R alpha. Once again, I tell you that this whole discussion was only based on numeric purpose. For if you want to learn these things in detail, go for refer your books or whichever material you prefer. This is only numeric things we'll discuss here. That's it. And this video, all these videos will help you only when you complete this whole chapter, otherwise it won't help you anymore. Okay, so if you completed your whole chapter, then this will help you. Otherwise you did not understand what I'm talking about, or about all of this stuffs. Okay, so yeah, L is length of arc, and basically R alpha is side distance. Okay, so if we divide it by 2, so SD by 2 R. Okay, in it is in radian, we'll change it in non-degree. So alpha by 2 is equal to SD by 2 R into, wait a second, yeah, SD by 2 R into 180 degree divided by pi. So yeah, this is all about for single lane offset back distance. Let's move forward to our for multi-lane. Okay, so our second part, yeah, our second part for multi-lane. Yeah, before that, let's draw another diagram for this. So it's something like this and something like this. Here we have another curve like this, and here we have dotted line, just something like this. Yeah, yeah, yeah. Here this is shit. Basically, draw it with this. Yeah, this is something like this. Yeah, and this is our, yeah, this is our setback distance. Here it is r minus d. It is alpha by 2. Here also it is alpha by 2. This is center line of, this is center line of inner line of inner, basically center line of inner line, and it is center line of road. It is center line of road. Okay, this distance, basically there is one more from here. Yeah, this distance is d, and here it is ssd minus s. Okay, so this is all about diagram for multi-lane. Let's move forward to its formula. Yeah, so for multi-lane, let we have for let we have width total width is equal to 2d, and for two lanes, shit, yeah, for two lane, m is equal to r minus d cos alpha by 2, and for n lanes, m is equal to r minus n minus 1 into d into cos alpha by 2. Okay, so this is for n lanes and this is for 2 lanes. And setback distance from the center of line of inner lane. So another thing, that setback distance from the center line of inner lane. Center line of inner lane. So this is equal, m is equal, shit, m is equal r minus d minus r minus d into cos alpha by 2. Okay, and alpha by 2 is equal, yes, d side distance into upon 2, yeah, side distance upon 2 r minus d into 180 by pi, 180 by pi. And for n lane of road, this formula will be is equal to, yeah, for n lane, this formula will to modify to m is equal to r minus n minus 1 into d minus r minus n minus 1 into d cos alpha by 2. And our alpha by 2 is equal to side distance upon 2 r minus n minus 1 into d into 180 by pi. So this is for n lane. Okay, this formula is in condition when set for setback distance from center line of inner lane in under multi-lane condition. Okay, so this is all about case first, where length of horizontal curve is greater than side distance. Let's move to case 2. Case second, when the length of horizontal curve less than side distance. When the length of horizontal curve is less than side distance, that is LC less than side distance. Again, we'll discuss it for single lane and for multi lane. For single lane and for multi lane. For multi lane. Okay, so let's discuss first for single lane. Before that, let's draw a diagram for the sake of simplicity. Yeah, let's diagram something like this. Let's draw a dotted line from here and another dotted line from here. Okay, draw this, here, this, again, let's draw this line. This is alpha by 2. Yeah, that's A, B. This is our center line. Yeah, this is our center line. Center line, okay. And this is our LC, length of horizontal curve. Okay, this is when LC less than SD. Okay, so we have formula for single lane, which is M is equal to R minus R cos alpha by 2 plus S minus LC by 2 into sine alpha by 2, and alpha by 2 is equal to LC by 2R into 180 by pi. Okay, and for multi-lane, let's move on to next page for multi-lane, because we'll need to draw another diagram for that. For multi-lane, let's draw a diagram for that, something like this. Yeah, there's one line here. Yeah, make it to further. Okay, draw here for an angle. This is obviously alpha by 2, and move it further. Okay, yeah, this is basically, it is something like this. This is from here to here. A to the basically, this is LC, and this is center line of road, center line. Okay, and this is center line of inner lane, center line of inner lane. Okay, this is condition when LC less than SD. Okay, for 2-lane condition. Okay, there it is, S minus LC by 2. Okay, so we have a formula for setback distance. M is equal to R minus D cos alpha by 2 plus S minus LC by 2 into sine alpha by 2. Okay, and obviously alpha by 2 is equal to LC upon 2R minus D into 180 by pi. Okay, and yeah, setback distance from center line of inner lane. Setback distance from center line of inner lane. Center line of inner lane. We have a formula: m is equal to r minus d into r minus, sorry, m is equal to r minus d minus r minus d into cos alpha by 2 plus s minus lc by 2 into sin alpha by 2. Okay, and alpha by 2 is equal to 180 into lc upon 2 into r minus d. So this is complete formula. Do remember all these formula, because these are very important in geometric design. Okay, all these formulas very important for solving numericals. There is a lot of numericals from here also. Okay, let's move forward to summit curve. Yeah, basically summit curve is our, you know, our last topic. No, this is second last topic. Our last topic is valley curve. So yeah, let's discuss summit curve. Let's only discuss only formula of summit curve. Okay, so yeah, summit curve. And summit curve, there is a one deviation angle there. We have a formula for that. Basically the deviation angle is uh sorry, there is deviation angle in summit curve. Deviation angle of summit curve, basically we'll denote it by n. So n is equal to plus n1 minus n2. So basically it will be n1 plus n2. So design of summit curve. We already know that there is a parabola type of thing there. Summit curve, let's say parabola's equation y is equal to ax square, and where x, let's say x equal to l, y is equal to ln by 2. So we'll get a is equal to, and ln by 2, a is equal to n by 2 l. As if you put x is equal to l here and y is equal to ln by 2, then you'll get n by 2 l is equal to a. So our formula will be is equal. So our formula equations, so our equation of parabola is y is equal to nx square by 2 l. Okay, so yeah, this is all about equation of parabola for design of summit curve. Let's move forward to radius of curvature of summit curve, which is basically, yeah, uh, oh shit, I'll put a space there. So yeah, it is summit curve. Let's move to next pages. Yeah, radius of curvature of summit curve. Radius of curvature of summit curve. Basically, it is equal to 1 by 2a. That is r is equal to l by n. Okay. but the minimum radius of summit curve should be such that the rate of radial deceleration should not be greater than what? Should not be greater than 0.75 meter per second square. Okay, so what? the minimum radius the minimum radius of summit curve, do remember this thing, the minimum radius of summit curve should be such that the rate of radial deceleration the rate of the radial deceleration should not be should not be greater than 0.75 meter per second square. Okay, so there is a limiting value for r, which is equal to r is equal to 0.278 v whole square upon 0.75. Okay, and we have also a table for this, for in between speed and minimum radius of summit curve, which will help you on to solve numericals. So what it is, basically we have here speed in kilometer per hour, it is here minimum radius, so speed 25, 30, 35, 40, 50, 60, 65, 80, and 100. So if you have a speed of 25 kilometer per hour, then you'll get a minimum radius, you should be have minimum radius of 65. For 30 it is 95, for 135 it is 130, for 40 170, and for 50 250, 6 for 60 380, for 65 440, and for 80 it is 670, and for 100 it is 1045. Yeah, do remember this table, it will help you to take assumptions while you'll solve numericals. Okay, so yeah, one more thing in summit curve, it is that length of summit curve. Okay, so we'll discuss length of summit curve. What? Length of summit curve. Basically, before that, let's draw a diagram for the sake of simplicity. Yeah, wait. Something like this. Here, this is deviation angle, n1 plus n2 is equal to n, and something like this. It is h. Here it is h, and yeah, this is s1 and this is s2. S1, S2 is complete. This whole is S. Okay, this is S. Obviously, this is plus N1. That is minus n1 minus n2. Okay, this is h, small h. So yeah, so for find length of summit curve, we'll have two conditions. First one is when length of curve exceeds the required side distance, and case two when the length of curve is less than the required side distance. Okay, so we'll discuss both the condition. So case first, when length of curve is greater than side distance. Okay, so then we'll have formula ns square upon 2 under root h plus under root h whole square. Okay, this is our formula for when length of curve is greater than side distance. Here h is basically, here h is height of eye of driver from road surface, and a small h is height of object above the pavement surface. Okay, h is height of oh height of eye of driver from road surface, eye of driver from road surface, and small h is height of object above pavement surface, height of object above pavement surface. Yeah, so for ssd, if h is equal to 1.2 meter and small h is equal to 0.15 meter, then we'll get L is equal to ns square upon 4.4 meter. And okay, and for ISD and obvious ISD and OSD, if we have will have safe condition, if we have same condition, s equal to 1.2 meter and small h is equal to 0.15 meter, then we'll get L is equal to ns square upon 9.6 meter. Okay, so this is all about when length of curve is greater than side distance, required side distance. Let's move forward to our next condition, next case second, when length of curve is less than required side distance. Then we'll get formula of L is equal to 2s minus 2 under root h minus under root small h whole square upon n into meter. And for SSD, we'll have L is equal to 2s minus 4.4 upon n meter. And for ISD and OSD, for our ISD or OSD, we'll have formula L is equal to 2s minus 9.6 upon n meter. N meter. Okay, so this is all about summit curve for two condition when length of curve is greater than side distance, and when length of curve is smaller than side distance. Okay, length of curve is greater than side distance and length of curve is smaller than side distance. Let's move forward to our next topic. Before that, give me a second so that I'll set this pages. Yeah, our next topic, which is valley or shag curve. Valley or shag curve. Yeah, basically a valley curve is vertical curve with concavity upward and convexity downward. Okay, so for better understanding of valley curve, let's draw a diagram for that. So yeah, basically belly curve is vertical curve with concavity upward and convexity downward. Okay, it's just yeah something like this. Here minus n1 and it is plus n2. Okay, it is our deviation angle, n is equal to minus n1 minus n2. Okay, n is deviation angle, n is deviation angle. Okay, so yeah, let's move forward to length of valley curve. What length of shit, length of valley curve. So basically we have two conditions. First one is based on comfort condition. So based on comfort condition, length of valley curve is equal to 2 into ls is equal to, so basically we also have ls is equal to nv cube upon c. Okay, c is rate of change of centrifugal acceleration. Remember one thing here, which is c, rate of change of centrifugal acceleration is limited to a value which is 0.6 meter per second cube. Okay, shit, 0.6 meter per second cube, and our length of valley curve lv denoted as lv is equal to 2 ls. Okay, so lv is equal to 2 n v cube upon c, and if c is equal to 0.6 meter per second cube, then lv is equal to, lv will be 0.38 n v cube power 1 by 2. Okay, so yeah, this is all about the length of valley curve for condition when based on comfort condition. And our next condition based on headlight side distance. Okay, so next condition is based on headlight sight distance. Headlight side distance. Before that, let's draw a diagram for the sake of simplicity. Yeah, something like this. This will be something like this. Yeah, let's say there is your vehicle, something like this. Okay, yeah, this is your vehicle here. This is your vehicle. So this is impact something like this. So it is this angle. This angle is headlight angle. Okay, headlight angle. Headlight angle of this car. Basically, this car, there's a headlight here, which is something like this, and this angle is headlight angle. Okay, and this line is line of sight. Line of sight. Okay, So here also we have two cases. Case first, when length of valley curve is greater than headlight side distance, then LV is equal to ns square upon 2h plus 2s tan alpha. Basically alpha is beam angle. Okay, so if we have h is equal to 0.75 meter and alpha is equal to 1 degree, then we'll get LV is equal to ns square upon 1.5 plus 0.35 s. Okay, so this is our first case when length of valley curve is greater than headlight side distance. Let's move on next case, which is when length of valley curve is less than headlight side distance. Okay, so that case second, when length of valley curve is less than headlight side distance, then we'll get formula LV is equal to 2s minus 2h plus 2s tan alpha upon n upon n. Okay, so here also if we have h is equal to 0.75 meter and alpha is equal to 1 degree, then we'll get LV is equal to LV is equal to 2s minus 1.5 plus 0.35 s upon n in meter. Okay, so yeah, here we completed our geometric design. This is all about everything we'll cover in geometric design for undergrad 2022 syllabus. Okay, we'll meet very soon for the previous year questions of geometric design. Okay, and after that we'll discuss traffic engineering and their previous year questions. Okay, till then practice a lot of questions, and yeah, best of luck for your gate examination 2022 and all your examination which you'll targeting for. Okay, till then take care, goodbye, thank you so much for watching this video, thank you so much.